Welcome to Japan Railway Journal. I'm Nikki Clark. Today we're at JR Central's SC Maglev and Railway Park. This museum displays 39 historic rolling stock, giving us a glimpse into the history of railway technology. This is the first Shinkansen, the Series 0, which started operation with the opening of the Tōkaidō Shinkansen line. It's been 60 years since the opening of the Tōkaidō Shinkansen. Its history can be described as a history of challenges to speed and technological development. Let's take a look back at the history of its evolution of speed.
The Tōkaidō Shinkansen is the main artery that connects Tokyo and Osaka. Currently, 356 Shinkansen trains operate daily, carrying approximately 360,000 passengers. The Tōkaidō Shinkansen began service in October 1964. This new high-speed train made the 550-kilometer trip between Tokyo and Shin-Ōsaka in 4 hours, with a maximum speed of 210 kilometers per hour. The vehicle that kicked off the era of high-speed rail was the Series 0 Shinkansen. Several designs were proposed during its development, but research in aerodynamics led to its iconic shape. The Series 0 also adopted a distributed traction system, with each car having its own motor. Until then, long-distance trains used concentrated traction systems, in which the lead locomotive pulled the entire train set. Japan has a varied terrain with many curves and slopes. For this reason, the distributed traction system, which facilitates smoother acceleration and deceleration, was better suited for running at high speeds. In 1975, the San'yō Shinkansen, operated by JR West, started full service from Shin-Ōsaka to Hakata in Fukuoka Prefecture. With a direct Shinkansen service between Tokyo and Hakata, the shortest travel time was 6 hours and 56 minutes. The Shinkansen soon became Japan's main artery, connecting many major cities. Following the development of the Series 0, the Series 100 was introduced in 1985. Although the exterior design was sharper, it retained the image of the Series 0. Increasing the output of the motor, the Series 100 was able to run at a maximum speed of 220 kilometers per hour. This reduced the travel time between Tokyo and Shin-Ōsaka to 2 hours and 49 minutes. In April 1987, Japanese National Railways, which operated the Shinkansen, was privatized and divided into 7 companies, 6 passenger operations, and 1 dedicated to freight. At the same time, the 4 existing Shinkansen lines were taken over by the corresponding JR companies. JR Central, which took over the Tōkaidō Shinkansen, aimed to increase its speed even further. However, the noise generated by the Shinkansen posed a problem. Shinkansen operations generate a lot of noise, from the running noise of the wheels on the rails to the wind that comes in contact with the car body's protrusions and pantograph. To achieve higher speeds, the noise problem had to be resolved. Following in Japanese National Railway's footsteps, JR Central developed even more effective noise barriers. In addition to the noise, another problem was the shock waves that Shinkansen generates when passing through tunnels. When a Shinkansen enters a tunnel, it pushes air ahead of it, causing a shock wave and a loud booming sound at the other end. That boom can rattle the doors and windows of nearby buildings, so shock-absorbing structures were installed at either ends of the tunnels. This reduced the impact of the shock waves by almost half. JR Central then developed the Series 300, a new vehicle designed to address these problems while further increasing speed. The overall weight of the Series 300 was also reduced. Until then, each Series 100 car weighed approximately 58 tons. That meant a 16-car train set weighed more than 900 tons. First to change was the materials used. The steel body structure of previous generations was replaced with a lighter aluminum alloy. However, aluminum alloys aren't as strong as steel, so the structure also had to be redesigned. To fortify the material strength, special aluminum alloy plates were molded with a T-shaped framework. Using these aluminum plates made it possible to remove the support pillars and beams, making the overall weight of the car body much lighter. While previous generations used a heavy DC motor, the Series 300 used a more compact AC motor, which also increased the power by 30%. This new compact motor was half the weight of its predecessor. The smaller motors meant the bogies could also be modified. The Series 0 and Series 100's bogies had a large horizontal bolster that connected the car body to the bogie. The newly developed bogie was bolsterless. The air springs were also improved, and new vibration control yaw dampers were installed. This enabled stable running without the bolsters. With all the modifications, the total weight of the Series 300 was reduced to 711 tons, 200 tons lighter than the Series 100. The lead car was also given a practical new look. To reduce noise and air resistance, the front section of the car body was extended downward. The pantographs were modified to generate less noise, and the total number of pantographs were reduced. In addition, the air conditioning units were downsized and mounted entirely under the floor, and the cars were lowered by 35 centimeters compared to the Series 100. the lower center of gravity enabled a more stable operation at high speeds. As a result of these improvements, the Series 300, which began commercial operation in 1992, could run at a top speed of 270 kilometers per hour, connecting Tokyo to Shin-Ōsaka in 2 hours and 30 minutes.
Here, the Series 0, Series 100, and Series 300 are displayed side by side. Even by looking at the lead cars, Series 100 looks like an evolution of Series 0, and Series 300 looks a lot different from the other two, giving the sense of how innovative vehicle they are.
You're right, actually. And not only that grand exterior, the inside, there are many innovative technologies. One example is the bolsterless bogie technology, and this contributed not only to the significant weight reduction, but also to the improved dynamic performance, especially when negotiating tight curves. And I can tell you that this is one of the key technologies in the realization of near 300 kilometers per hour operation on the Tōkaidō Shinkansen.
I see. Well, even though the Series 300 has already retired, the evolution of Shinkansen vehicles has continued to advance.
You're right, actually. After all, the technological development is always a never-ending story.
Yes. Next, let's take a look at the development after the Series 300.
After the privatization of Japanese national railways, the JR companies, seeking to increase the speed of their Shinkansen trains, developed a variety of different test vehicles. The first to take the lead was JR West. In 1992, Wing 350 set a record of 350.4 kilometers per hour, the highest speed in Japan at the time. Based on the data from this test train, JR West developed and launched the new Series 500 5 years later in 1997. The Series 500 began commercial operation on the San'yō Shinkansen section, running at a maximum speed of 300 kilometers per hour. Then, in 1995, JR Central developed the 300X. The 6-car 300X had different shaped front and rear cars. Car 1 had a slightly concave, pointed shape, whereas Car 6 had a more convex, wedge shape. This was to compare and analyze the different sounds and the force of the impact wave generated when passing through tunnels. In addition, the walls of the car body were designed with minimal window and door protrusions. The sides of the underfloor were also fully covered. This was done to reduce air resistance and wind noise. Also, to reduce the noise generated by the pantographs, various forms of pantograph covers were designed and tested. In July 1996, the 300X broke the Japanese record, reaching a maximum speed of 443 kilometers per hour. Based on 7 years of testing and data obtained from the 300X, the Series 700 made its debut in 1999. This Series 700 was jointly developed by JR Central and JR West. Its most distinctive feature is the shape of its lead cars. The long nose, which is even longer than car 1 of the 300X, was adapted to reduce impact waves when entering tunnels. And to reduce vibrations caused by the increased speed, a vibration control device called semi-active suspension was installed to enhance passenger comfort. The Series 700 travels at a maximum speed of 270 km per hour on the Tōkaidō Shinkansen section. On the San'yō Shinkansen section, which has less curves and slopes, it runs at a maximum 285 km per hour. The Series N700, introduced in 2007, had an even more advanced nose shape than its predecessor, reducing aerodynamic drag by 20%. In addition, a car body tilt control system was introduced. The system, a device that memorizes the route, tilts the car body in anticipation of the approaching curves, which reduces the centrifugal force, making the ride more comfortable. Then in 2013, the N700A, an upgraded version of the Series N700, was introduced with improved mechanics and equipment, increasing the train's acceleration. The improvements enabled the N700A to travel at a maximum speed of 285 km per hour, shortening the travel time between Tokyo and Shin-Ōsaka to 2 hours and 21 minutes. On the San'yō Shinkansen section, the maximum speed increased to 300 km per hour. And in 2020, the latest model N700S was introduced. The lead car's left and right sides were raised to improve aerodynamics and reduce noise. In addition, the underfloor equipment was made smaller and lighter. New power converters, half the size of the previous series, were also installed. Furthermore, the traction motors were made approximately 70 kilograms lighter by reducing the size of the electromagnets. The bogie frames were also lightened by 75 kilograms while maintaining the same strength. In operation, the N700S runs at a top speed of 300 kilometers per hour, but during test runs, it recorded a maximum speed of 360 kilometers per hour. Plus, a new feature was introduced. A battery-powered cell propulsion system. This system allows the vehicle to move to safety in the event of a power outage caused by a disaster. This year marks the 60th year since the Tōkaidō Shinkansen first began service. In response to demands for faster and more comfortable travel, Shinkansen technology continues to advance.
Behind us is the 300X, which set the world record with the top speed of 443 kilometers per hour. This is the lead car at the time the record was set.
You can see that the surface of the vehicle is very flat. Also, the lower part of the car body is completely covered. And don't you think that this looks like a record breaker?
Yes. Vehicles on display here once carried the title of world's fastest vehicle.
This C62 steam locomotive once was the fastest narrow-gauge steam locomotive at the recorded top speed of 129 kilometers per hour, which was recorded in 1954.
Wow, that's 70 years ago. A speed of 129 kilometers per hour must have been incredible at the time.
And the vehicle at the far end of this room is the test vehicle for the línea Chūō Shinkansen, now under construction between Tokyo and Nagoya. That vehicle set the world speed record in 2003 at the top speed of 581 kilometers per hour.
The línea Chūō Shinkansen is the superconducting maglev train line JR Central is currently constructing between Tokyo and Nagoya. Breaking the previous record for maglev vehicle of 581 kilometers per hour, a top speed of 603 kilometers per hour was recorded in June 2015. A superconducting maglev vehicle levitates inside a guideway using magnetic force. The magnets on board react to coils in the guideway, causing it to move at ultra-high speeds. The polarity of the magnets on board the train is set to north. In the guideway, the coils in front of the vehicle are set to south, whilst those behind are set to north. This effectively means the train is pulled forward by magnetic attraction while being repelled from behind at the same time. The superconducting maglev moves by switching the current that controls the polarity of the coils along the guideway. When completed, the línea Chūō Shinkansen will cover the 285.6 kilometers between Tokyo and Nagoya in just 40 minutes. In the future, there are also plans to extend the line from Nagoya to Osaka.
So the history of railway is also a history of technological development aimed at mass transportation and fast delivery.
That's right. You know, when you want to raise the speed of the railway line, you have to conduct research in various technical fields. And that means the outcome of that research might be able to be used to improve other railway services in other parts of the world. So that means the development taking place here may be benefiting other railway users in other parts of Japan as well.
I see.
On September 2nd, a tour of a steam locomotive that retired in March this year was held in Kitakyushu City in Fukuoka Prefecture. This steam locomotive last operated as a tourist train throughout Kyushu. During the tour, the participants got to watch the installation of the steam locomotive's connecting rod.
憧れの SL の中に入れ運転席に入れたってので、もうすごい来た甲斐ありますね。
On September 12th, in Nishikawa town in Yamagata Prefecture, repair work was conducted on a wooden train car that once ran in the prefecture. This train ran on the Yamagata Kotsu Sanzan line, which opened in 1926, until it was discontinued in 1974. It is now on display in the town's museum. Local volunteers raised 15 million yen through crowdfunding to repair the aging car body.
大正時代の雰囲気がやっぱりあるなというようなことで、タイムスリップ100年間できるかなというふうに思ってます。
On September 15th, a departure ceremony was held for special wrapped monorail at Tokyo Monorail's Haneda Airport Terminal 2 station.
出発進行!
This year marks the 60th anniversary of the Tokyo Monorail, which connects central Tokyo to Haneda Airport. To commemorate the 60th anniversary, the monorail was wrapped in the colors that were used when the line first opened. Rail fans lined up at the ticket gate to buy commemorative tickets.
地域の足としての使命を果たしていきたいというのがまず大前提であります。羽田空港にお立ち寄りの際はご利用いただければと。